Good morning. Today we're going to be starting our new unit on Unit 6, and that is on right triangles. We're going to need to review how to simplify roots and radicals in order for you to be able to work with Pythagorean theorem with right triangles. Just a quick reminder, if we have a square of something, like 5 squared, that's the same as 5 times 5, and that's equal to 25. A square root, let me switch pens here. A square root is actually the opposite or inverse of that operation. Taking a square root, I know that 25 has 2 5s that make it up. So those roots are our answer. Okay, so what we're doing today is looking for roots. Now there's 2 ways that you may have learned this. You may have learned it by looking for a square root within the number, or you may have learned it by doing the prime cake method or making a prime value factorization. I'm going to show you both ways. You can use whichever way you want. I like the prime factorization method, although it can take a little bit more time. So the very first step is to check using a calculator to see if you get a decimal. So, for example, for the first problem here, square root of 8, if I close my calculator and I take a look, I'm like, okay, let's take the square root of 8. It's going to give me a decimal. If it's a whole number, then your answer is a whole number and you can move on, like the square root of 25. However, if it's not, if you get a decimal like I have just done, then we're going to need to simplify that radical. Okay? So let's take a look at how we would do that. First, I'm going to show you the prime cake method. Okay, so if I'm looking at 8, what I need to do is divide this into its prime factorization. So that means I have to use prime numbers, okay, and I'm going to keep dividing this number by a prime number until I have divided it out to 1. Okay, the ones that you're going to be using the most are 2, 3, 5, and 7. And honestly, 2, 3, and 5 are the most important. 7 and 11 are your backups if you can't find anything else. Remember that if it's an even number, I can usually divide by 2. So I'm going to start with 8 down here, and I put a little division symbol, and I know I can divide by 8 by 2. So I divide 8 by 2, and I'm going to put my answer on top. Now we can still divide this up more. So I look at my primes. It's an even number. I can divide by 2. So I'm going to divide again. It's kind of like a step ladder or a cake. I divide by 2 again. I get a 2. Okay, but I know I can divide 2 again because 2 divided by itself is 1. Once I finish up and I get a 1, it's like the candle on the cake. I know I'm done. These numbers, if I multiply them back together, 2 times 2 times 2 is going to give me 8. So now I know that the square root of 8 is actually equal to 2 times 2 times 2. Okay? So just like square root of 25 had a pair of 5s, anytime we see a pair of values, that actually represents the square root of something. Like this 2 times 2 is 4, and the square root of 4 is 2. So I take this pair, and it takes one pair to take 1 out. So down here I'm going to put a 2 that's going to come out, and I cross that out. And the other 2, it doesn't have a partner, so it's going to stay in the house. Okay? So our answer here is 2 square roots of 2. And this is multiplication, 2 square roots of 2. Now I'm going to show you how to do it the other way, which is to look for square roots, hidden square roots. This requires that you are able to recognize your square roots when you see them, okay? So 72, if I divide it by 2, I know that 72 divided by 2 gives me 36. So that's the square root of 2 times the square root of 36. That would give me back 72. Okay, I know that 36 is a perfect square. The square root of 36 that breaks up into 6 and 6, right? So this is actually, if I put the square root in front, 36 times 2. The square root of 36 is 6. So I can take this out because I know that if I take the square root of 36 and just, I know my square roots, I know it's equal to 6. Just like I know the square root of 25 is 5. So I get 6 square roots of 2. This is a lot faster, but again, you have to be able to identify where your square roots are in a value, which make it tough. If you're more comfortable using this method, please feel free to do that, okay? I'm going to show you the prime cake method of this as well. Instead of doing it this way, if I'm not really sure that it breaks up what square root it might break it to, I'm going to take 72 and I'm going to divide it by 2. I know it's an even number. Or actually, let's divide by 3 this time. I know it divides by 3 also. If I divide it by 3, I get 24. And I just chose 3 just to start with a different number. I know 24 divides by 3. And I know that gives me an 8. You can use your calculator for this part. 8 divided by 2 gives me a 4. 4 divided by 2 gives me a 2. And 2 divided by 2, remember I have to do the last one, gives me a 1. Once I get a 1 on top, I know I'm done. It's like the birthday candle on the cake. I need to take all of these numbers, and they're going to go inside. Okay, so 72 is actually equal to 3 times 3 times 2 times 2 times 2. It's a lot of numbers. Now we find any pairs, and each pair means that they can come out of the house. You have to have a pair of people to come out of the house. So a pair of 3s brings 1 3 out. A pair of 2s brings 1 2 out. And we're multiplying here all the time. Even if they come out, they're still being multiplied. So the only one left inside is this 2. Okay. And now that I've brought everything out or left it in as needed, I have 3 times 2, and that's going to give me a 6. And then I have my square roots of 2. So you can see, whichever way you go here, if you're able to find a hidden perfect square, take the square root and bring it out, or using your prime factorization cake, both of those methods work. Whichever method that you have learned and or that you're comfortable with, that's the one that you should go with. Okay, we're going to do a couple more, and then I'm going to have you check your work, okay? So let's, why don't you take a moment to try whichever method that you prefer for the square root of 48. I'll give you a minute. You can pause the video. Okay, so 48. It's an even number. So I'm going to start dividing by a 2. Now, it's really tempting here to be like, I can divide this by a 4. But remember, prime factorizations, we're only dividing by the numbers that are prime. Okay? You can't use a number that's not prime to divide it out, because then you're not dividing it into its smallest possible parts. So I'm going to start by dividing by 2. And that is going to give me 24. Divide by 2 again, and it gives me 12. Divide by 2 again, and it's going to give me 6. Divide by 2 again, and that gives me 3. And finally, I can divide 3 by itself, because 3 is a prime. And that gives me my 1, so I know my cake's done. So now I'm going to put all of these numbers under the radical. 2 times 2 times 2 times 1, 2, 3, 4, 2 times 3. If I multiply these back together, I'll get 48. Then I take any pairs that I have, and the pairs are going to go on the outside. I have a pair of 2s, I bring 1 2 out. I have a pair of 2s, I bring another 2 out. 1 comes out for each pair inside. Then all that's left is the 3. Okay? That's going to give me 2 times 2 is 4 times the square root of 3. This is 4 square roots of 3. That's my answer, okay? Alright, so hopefully you got that right. I'm going to show you just a couple more, and then you should have some time to practice, okay? So the first thing is, what happens when you come up against a number like the number of 17? If I take 17, you'll notice it is a number that's already listed up here as prime. So I can't divide it by anything other than itself. If I tried to make a factor cake out of this, I can't divide it by 2, 3, 5, 7, 11, it's prime. It only divides by itself. So 17, I get 1. So the only number underneath is 17. That means it's already in its simplest form. Okay? So this, if it's a prime number, it's already in its simplest form. It doesn't simplify further. Let's take a look at this. We're going to skip down, and I'm going to skip over 1, 2, 3 to the square root of 22, because this is another one that ends up being unable to be simplified. And you're like, but wait, it's not prime. And you're right, but watch what happens. If I have the square root of 22, and I divide it, I can divide it by 2. I get 11. But 11 is one of those prime numbers. It only divides by itself. So then I have to take my 11, divide it by an 11 to get my 1. Remember, I have to have a 1 at the top to be done. That means that inside, I put my 2 times my 11. Notice how there aren't any pairs? That means that nothing comes out. And since nothing comes out, that means its simplest form is still just square root of 22. Okay, that's our answer, just like 17. So sometimes either if the number itself is prime or nothing comes out when you do your prime factorization, then it is in its simplest form. That's the best you can do. Okay? All right, let's take a look at a couple other ones just so that you're aware on how to do them. And then you're going to do some practice on your own. Okay? 125, I want to show you this one because if it ends in a 0 or it ends in a 5, it's divisible by 5, right? So you can divide by 2 and 3 most of the time, but if it ends in a 5 or a 0, try dividing by 5, okay? Divide by 5, that's going to give me 25. Now I can divide that again by 5. And if you were doing it in the other form, you might recognize that 25 is a perfect square, and you could go from there, right? But I have 25 divided by 5, and I get a 1. So this one's pretty short. I have 1, 2, 3, 5s. All of the ones on the steps go inside, 5, 5, and 5. And then I look for pairs. Remember, it takes a pair to bring 1 out. So I draw my square root. I have a pair. It takes 1 pair in the house to take 1 out. Okay? Then I have 1 that doesn't have a pair, so it stays in, and the answer is 5 square roots of 5. All right? Let's do one more together. I'd like you to try this one on your own first, so if you could pause the video, and then I'll go over it with you. Okay, so hopefully you got 3 square roots of 35. Let's run through this. I have 315. I see that it ends in a 5, so I'm going to divide by a 5. That's going to give me a 63. Since it ends in a 3, I know it's odd. I can divide by 3. It gives me 21. Divide by 3, it gives me a 7. Remember, 7 is one of our prime numbers. It's the only number you can divide it by is 7. And that gives me a 1. So I'm all set. I have 5, 3, 3, 7. So all of those will go under 5 times 3 times 3 times 7. Now I have a pair of 3s. So when I draw my square root, the 3 comes out, but I'm left with a 5. And remember, this is multiplication times 7 inside. That's okay. Just like we've multiplied numbers together that are on the outside, like when we did 2 times 2 and 4, here, I just multiply these together. Since they can't come out, they stay together, we recombine them, and you get 3 square roots of 35. Okay. So at this point, you should pause the video and you should try the rest of the problems on your own. I want you to check your work. At the end of this video, you can unpause, or I will post the answers to Schoology. Okay. So you should have tried these on your own, and now you're just checking your work. The answers are here. You can pause the video to check. If you got one of these wrong, go back and check. Did you divide by a number that wasn't prime? Remember, you can only divide by numbers that are prime, right? Also, did you maybe take out 2 instead of taking out just 1 for a pair? Those are things to check if you're finding it a little off, and also check with your partner.